Okay, in the next video here, we're going to learn how to make arrows, not arrows to things. So up here near the top, I'm going to add a new object, which will be an arrow, which is a built-in object in VPython. The arrow needs to have a location, and that's its position, and I'm going to set it now at the origin, 0, 0, 0. It also needs to point in a particular direction with a particular magnitude, and that is the axis of the arrow. That's also a vector, and for starters, I'm just going to have it point 2 to the right, 2 down, and 0 in the z direction. And then I can give it a color, and I'll make the color blue, so it stands out against my red trail. Let's take a look at that. Okay, so I have an arrow, it's pointing right and down, and it is not doing anything particularly interesting right now. Okay, a static arrow is not particularly helpful, but I can make this arrow, now that I've created it, I can make it do whatever I want. So I'm going to give it a name just for starters. I'm going to call my arrow Susan for no particular reason at all. Then I can go down here inside my code, since Susan is a thing that exists, and I can do things with that arrow. I can update its axis and update its position and so on. So I'll put a line of code down here that says update the arrow. Okay, under that, I'm going to change the axis of Susan, the direction it points and its magnitude, and I want to have it point at the ball everywhere the ball goes. So the position is still the origin, but the axis will point at the ball. To do that, the axis needs to be the vector that points directly to the ball, which is ball1.pos. So I've run that. We have an arrow that points always to the ball. It gets a little bit big, so let's play with that a little bit. Well, we may not want the arrow to point at the ball's position at all. Maybe we want to follow along with the trajectory of the ball, and we want to show the velocity of the ball at all points. Right, I could have the axis be equal to the velocity of the ball, which I already have right here in line 24 is just v. So if Susan's axis is v, then we'll have an arrow that is always at the origin, but has a direction that points in the direction of the velocity of the ball. Looks a little funny, it's very large, and we would like to have it kind of follow the ball along as the ball goes, kind of what we're used to seeing in our Logger Pro. So I can change, let's see, not the axis, but the position of Susan, of the arrow. And I'm going to put the position at the location of the ball, so ball1.pos. So now it's located on the ball, and it points in the direction of the velocity. So there we go. I think I might need to zoom out a little bit. I can set the range here maybe to 15 or so to give me a little more space. And that arrow looks a little bit big, so I'm just going to scale it down to about a third of what it was. And there we go. I'm going to slow down the rate also. It's going kind of quickly, so I'll slow it down by about a factor of 2. And now we have an arrow that falls along with the ball's velocity. And you can do whatever else you could dream up with the velocity vector, or sorry, the random vector, the Susan vector, and make it point in the direction of anything. I do have a force of gravity that points downwards, and that should result in a downward acceleration for the ball. And that's defined right here. So if I were to say that the Susan axis is equal to a, the acceleration, and then run, then I see the vector always pointing downwards in the direction of gravity. So use your arrows to do whatever is helpful for visualization or diagnosis.